Hey guys, it's Miss Meneely, and I'm going to give you a quick introduction to our third chapter in AP Statistics. So far in Chapter 1, we were looking at just displaying data in different ways. So I think in the first section and the second section, that was mostly what you did in your summer assignment, where you looked at the difference between categorical and quantitative data, and then also the displays that we use for each. And then in Chapter 2, we started looking at modeling data. In Chapter 3, we're looking at relationships between two variables or between bivariate data. And we're going to really concentrate on quantitative data, although you're going to see that there are ways that we can incorporate categorical variables into our data displays. We've done a little bit with relationships between two variables in Chapter 1, but we were focusing more on categorical relationships and looking at like two-way tables and a side-by-side bar graph. Now we're going to be looking at scatterplots and modeling relationships that we see in a scatterplot. So you've done this before in Algebra 2. I think you did a lot in Algebra 1 as well, and perhaps maybe even in pre-calculus. So we're going to begin by just looking at associations in the data and knowing how to describe the display that we see. If you remember, we did this with one variable data where we talked about the shape, the center, and the spread. We're going to be describing relationships in bivariate data a little bit differently. But first, we're going to be talking about the difference between what we would call an explanatory and response variable. You're used to talking about X and Y or independent and dependent variables. When we're moving into statistics, we're usually trying to see if there's a relationship between the two variables. If one variable is somehow influencing the other or causing or producing a response in the other variable. And so we kind of redefine them a little bit. We're going to be making scatter plots and then again, like I said, describing those relationships. But we're going to be talking about the direction, the form, and the strength of those relationships instead of the shape, center, and spread that we used with one variable. Okay, so to get us started, most statistical studies involve more than one variable. We're looking at relationships. Sometimes we want to compare the distributions of the same variable over several groups. So for example, if I wanted to look at like boys' scores versus girls' scores, or if I wanted to compare test scores in two different classes, it would make sense for me to do like a side-by-side box plot or stem plot or even two histograms to make that possible. But in this section, we're going to concentrate on the relationships among several variables for the same group of individuals. And the primary questions that we're going to ask, first of all, are what are the individuals? Who is it that we're describing? What are the variables and how are they measured? That's really important to make sure that we're consistently measuring them the same way for our sample. And are the variables quantitative or categorical? And that's another important question because that's going to change the displays that we used. And do we want to simply explore the nature of the relationship, or do we suspect that one of the variables may explain or possibly cause changes in another? And that is, are some variables response variables and others explanatory? So let's make sure we understand the difference between an explanatory and a response variable. An explanatory variable is one that attempts to explain the observed outcomes. It's sometimes referred to as the independent variable or a predictor variable, and it's usually going to be represented by the variable X. The response variable measures the outcome of a study, and it's sometimes referred to as the dependent variable. And so we usually use the variable Y to represent a response variable. So I think in science class you use the terms independent and dependent. Even in math classes, I think you've just used independent and dependent. Well, once we start getting into studies and we're doing research and we're looking to see how different variables relate to each other, we can usually distinguish between an explanatory and response variable. It's not always the case. So for example, if I'm looking at SAT scores and I'm looking at the relationship between the math scores and the verbal scores, I don't necessarily think that the math scores are explaining the verbal or that the verbal are explaining the math, but I do suspect that there's an association there that, you know, the better someone does on one section of the test, the better they're going to do on the other. Maybe not with the same rate of change, but I would still expect probably a positive association. We'll talk about what that means in just a second. But there are other types of relationships where I do think that perhaps one variable is explaining the outcome. So for example, if we're thinking about like weight gain. So if I'm looking at the amount of fat consumed, you know, or the number of calories consumed by a bunch of different individuals, and then I also measure their weight, I would expect that the number of calories consumed could have some explanation as to the weight that they are currently measured at. So sometimes we just think that maybe two variables are related. Sometimes I think that one may explain the outcome. And so we're going to look at some examples in just a second. One of the things that I do want to make sure that we distinguish between, though, is that just because we see a relationship between two variables doesn't necessarily mean that one of them is causing the change. So notice the note at the bottom of the screen. In many studies, the goal is to show that changes in one or more explanatory variable actually cause the changes in the response variable. However, other explanatory response variables don't involve direct causation, and they're just looking for an association. It's very, very important that when you're describing an association, you don't use the word cause or causation unless you've performed an experiment, because an experiment is really the only way you can get to the root of what is causing a reaction, because you pretty much eliminate all of the other variables in the situation. It's a very controlled setting. We'll talk about experimenting in our next unit, but for now, if we're talking about an association between two variables, even if it's a very strong association, it doesn't necessarily mean that the explanatory variable is causing the response. It just may mean that there's an association there. That'll make a little bit more sense after we look at some examples. So on the following screen, you'll see you have 3 different examples, and what I'd like you to do is identify the variables that are present and then identify them as either the explanatory or the response variable. So I'd like you to go ahead and press pause right now and to go ahead and do that. Okay. So in number 1, it's asking, or it's giving you the information, alcohol has many effects on the body. One effect is the drop in body temperature. To study this effect, researchers give several different amounts of alcohol to mice, and then they measure the change in each mouse's body temperature in the 15 minutes after taking the alcohol. In this case, we are expecting an explanatory response situation, because it's talking about the effect of adding alcohol to the bloodstream. So because we're expecting a change, it would make sense to label one of these variables as your explanatory variable and the other as the response. Since it's the different amounts of alcohol that we expect to produce the change, or that we expect to affect the change in body temperature, the different amounts of alcohol would be our explanatory variable, and the change in body temperature would be the response. Number 2 is a little bit different. 2 and 3 and actually kind of give you an example of how, depending on how we frame the situation or depending on what lens we're looking through, we may be talking about the same variables, but in a different way. So in number 2, it says, Jim wants to know how the median SAT, math, and verbal scores in the 51 states, including DC, are related to each other. He doesn't really think that either score explains or causes the other. He's just looking for an association there. So our 2 variables would be the median SAT math and the median SAT verbal scores. However, because we're not expecting an explanatory response situation in this case, it wouldn't matter which is X and which is Y. We wouldn't really label one as the explanatory variable and one as the response. Not in that setting. However, in number 3, Julie is looking at some data, and she asks the question, can I predict a state's SAT math score if I know the verbal score? And the lens that she's looking at, or the perspective that she's using, is an explanatory response situation, where the verbal score, she suspects, can explain the math score. And if that's the case, then the verbal score would be your X or explanatory variable, and the response variable would be the math score. So it kind of depends on your purpose for the study, what you anticipate to be true, what your hypothesis is, and that will help frame how you're going to define your variables. But as you can see with problems 2 and 3, depending on our perspective, the way we assign the variables can change. Okay, when we're displaying relationships between 2 quantitative variables, we're going to use a scatter plot, because we're looking at basically 2 variables on each individual. So for example, the SAT data, the individuals in that case would be the states. Each state has a mean or a median SAT math and a median SAT verbal score. And so each state represents a point in the scatter plot, and I'm measuring it using the 2 variables. One of the variables is going to be measured on the x-axis, and the other is going to be on the y-axis. So a scatter plot shows the relationship between 2 quantitative variables. And it's important that you guys remember that distinction between quantitative and categorical. I really can't plot categorical data on a scatter plot. There are ways that I can introduce a categorical variable, and I'll show you that in just a little bit. But scatter plots are intended for quantitative data only. The values of one variable are going to appear on the horizontal axis, and the values of the other are going to appear on the vertical axis. Each individual in the data is going to appear as a point in the plot that's going to be fixed by the values of both of the variables. And we always, always, always plot the explanatory variable if there is one, on the horizontal or x-axis of the scatter plot. If there is no explanatory response distinction, then either variable can go on the horizontal and vertical. It doesn't really matter. So in like that second case situation where we're looking at just an association between the SAT math and verbal scores where we don't really think that one is going to be used as a predictor or an explanation, it wouldn't matter which is on the x and y. But in Julie's case, I'd want to make sure that my verbal scores are on the horizontal axis. Okay. Describing scatter plots. So if you remember when we were dealing with a histogram, so let me just draw a quick histogram. Okay, when we were looking at the distribution of one variable, we referred to the shape, the center, and the spread. And anytime I asked you to describe the distribution, those are the three things you had to mention in context. When we're dealing with a scatter plot, that's going to look a little bit different now. And most of our scatter plots are going to be plotted in the first quadrant because when we're dealing with real data, it's almost always going to be positive. So a scatter plot, say, looks like that. So I'm going to be describing instead, I can't really talk about the center of this distribution or the spread or even the shape. We are going to talk about the shape, but we call it something else. In this case, we're going to be looking at the strength, the direction, and the form. And the form kind of goes along with the shape of a histogram in the sense that we're looking to see basically if a distribution or if the relationship between the two variables is linear or not. And so those are the three characteristics that we describe. We also, again, just like with histograms, we also want to describe any departures from the pattern. So if there are gaps or outliers. So for example, if in the scatter plot I had a point way over here, I would want to make sure that I comment because this is a possible outlier. So if there's any deviations or departures from the pattern, I also want to make sure that I comment on them as well in the context of the problem. Okay, so what do we mean by direction? You guys have done this in Algebra 1 and Algebra 2. Two variables are positively associated when above average values of one tend to accompany above average values of the other, and below average values of one and the below average tend to occur together. So if I think about my x and y axis, so if this is my x-axis, these are the low values of x, these are the high values of x. These would be my low values of y, these would be my high values of y. And if you think about this area in here, my low values go together. When you think about this, my high values go together. But when we look at a negative association, doing the same thing, notice that for x, when x is low, y is high. And likewise over here, when x is high, y is low. So the negative association is just reversed. When above average values of one accompany the below average values of the other. So there is an FRQ that I'm going to have you guys do, and it's actually from the most recent administration of the AP exam. And one of the questions asks is, how to describe what does it mean for an association to be positive? And a lot of people got this wrong because they didn't explain it clearly. You want to make sure that you're describing that when it's a positive association, the high values of one are corresponding to the high values of the other variable, and that the low values also correspond together. If there's no association, then usually you see just a random scatter of points. There's no trend. It's not obvious that you wouldn't want to model the data using an equation. It doesn't really look like there's an association. Okay, when we're talking about form, this kind of goes along with the shape of a histogram. Form is describing whether or not the distribution is, or the relationship is linear. A linear relationship is very obvious, and so that's usually where we start, is the relationship linear or is it nonlinear? Or is there no association, as we saw in the last one? So when you're asked about the form, you're basically asked, would a straight line pattern, it doesn't follow a straight line pattern, would a straight line model be appropriate for the data? So form is just asking, is it linear or not? And the strength, usually we're talking about the strength of a linear association, but you can also talk about the strength of a nonlinear association if there's a clear trend in the data. So a weak association, you can still see an association. One of the things I tend to do is like draw an oval around the points. So if my oval is more circular, if it's a really wide oval, I know that it's going to be a very weak association. But if I try to like circle my points here, I can see that my oval is a little bit narrower, and that tells me that I have a moderate association. And then obviously in this last one, I've kind of made my oval a little bit wider than it needed to be. In this case, I mean, those points are really, really close to a straight line. So that would be a very strong association. And just like what we did with histograms, when we started talking about the center and the spread, initially we were just being very subjective in our descriptions, and then later we started adding numeric summaries to those descriptions. So then we started talking about like either mean or the median or the standard deviation and the interquartile range. We're going to do the same thing with descriptions of bivariate data. So we first start off just kind of giving our impression of a scatter plot and saying, yeah, it looks weak, it looks positive, it looks like it could be a straight line. But then we'll start putting numerical summaries to the data to make it a little bit less subjective and more objective. So for example, this scatter plot gives you data on the percentage of students taking the SAT in different states and the mean SAT score. And so if we're talking about the strength, the direction, and the form, let's just talk about the strength. I can see that it actually looks like there's maybe two groupings of data here. If I look at it like from here to here, it looks like almost like there's two groupings of data. But so you could actually model both groups separately. If we want to look at the whole group, in terms of the strength, I can definitely see a trend here. But the points aren't like really, really close to a straight line or a curve. They're sort of scattered about, but they're not like completely random either. So I would say that this is probably a moderate association. And again, this is subjective here. When we say moderate, you could say it's moderately weak, moderately strong. I don't think it's weak and I don't think it's strong. It's somewhere in the middle. In terms of the direction, I think you can see that the pattern is decreasing. That is not enough to say that it has a negative association on the AP exam. Just to say that it's decreasing isn't enough. You have to mention something about the association between the variables, where the high values of one variable correspond to the low values of the other. So in this case, there is a negative association. And in terms of the form, again, this is subjective. Does that look linear or nonlinear? Would it be appropriate to model this with a straight line? It's a judgment call. What we're going to do in the later chapters is actually start modeling the data and trying different models to see which is the most appropriate, and then it becomes a little bit more objective when we assign numbers to those things. But at this point, it's kind of a judgment call. You can say it's linear, you can say it's nonlinear, but that's essentially what we're talking about here. And I'm going to go ahead and say it's linear. Then, of course, you want to make sure that you're describing this in the context of the problem. So we're talking about the percentage of students taking the SAT and their average math score on that exam. And so if you were to describe the scatter plot in the context, this is just an example. There's a moderately strong negative curved relationship between the percentage of students in a state who take the SAT and the mean SAT score. So there's your context. Further, there are two distinct clusters of states and two possible outliers that fall outside the overall pattern. And so those outliers could be perhaps this value here and this value here, where we had a large proportion of students taking the SAT and a very, very low mean score. Okay, but that's pretty much what you want to do when you're describing the distributions. Okay, so with the next example, I'm actually going to go ahead and skip it because it's not on your paper. The next example, you've got three graphs, and this gives you information on the jet skis and the number of jet skis in use, and the number of manatees, I'm sorry, not number of manatees, the number of fatalities over time. So it says, propelled by a stream of pressurized water, jet skis and other so-called wet bikes carry from 1 to 3 people and have become one of the most popular types of recreational vehicles sold today. But critics say that they are noisy, dangerous, and damaging to the environment. An article, and sorry, it's kind of old, an article in the August 1997 issue of the Journal of American Medical Association reported on a survey that tracked emergency room visits at randomly selected hospitals nationwide. Here are several scatter plots relating the number of jet skis in use, the number of accidents, and the number of fatalities for the years 1987 to 1996. So if you take a look, you're given 3 different graphs, and you're asked to describe the association between the variables in the context of the problem. I would like you to complete these 3 examples as part of your homework assignment. And I'm going to go ahead and move on. I'm not going to pause, and I'm not going to give you the correct answers. I want you guys to do that. If you look at the second example, you're given some more examples on identifying an explanatory and response relationship. Some of these answers depend on how you perceive the problem and how you're looking at it. Answers could vary, but there are some that I think are pretty obvious in terms of which is the explanatory and which is the response, and others that there may be a discussion about. But I'd like you to go ahead and do number 2 as part of your homework assignment as well, and we'll talk about the associations in class. And number 3, I want to do with you. So it says in number 3, how does fuel consumption of a car change as its speed increases? Here are the data for the British Ford Escort, where speed is measured in kilometers per hour, and fuel consumption is measured in the liters of gasoline that is used in 100 kilometers. So the way they're measuring gas mileage is different than the way we measure gas mileage. We measure how many miles you can go on 1 gallon of gas. The way they measure fuel consumption in, I guess, Great Britain is how many liters of gas does it take to go 100 kilometers. So it's measured a little bit different. So the first thing you're asked to do is construct a scatter plot of the data using your graphing calculator, and then to sketch it below, and then to label and scale your axes appropriately. When I ask you to scale your axes, it's enough for me just to put your minimum and maximum of the x and the y values. Then you're going to be asked to describe the association. So go ahead and press pause if you need to, and enter the data into your calculator. I've already done it, so I'm going to go ahead and move forward. So I've got the data in my calculator already. I've entered the speed and the mileage. So again, one of the things you want to think about when you're entering data is making sure that your explanatory variable goes in the x, is your x variable. And since I would expect speed to impact or to explain the gas mileage, I'm going to say speed is my explanatory variable, and I'm going to let mileage be my response. And so it's important too that you label your variables just like we have all along. And notice that I broke the table up into 3 sections just to save space on the paper, but you want to make sure that you enter all of your speeds in list 1 and all of your mileages in list 2. When you're constructing a scatter plot, we're going to go back up to our stat plot menu. And it doesn't matter what plot you work in. I'm going to continue working in plot 1. And when you choose the type, you want to choose the very first option. That's your scatter plot. Make sure your x's are coming from the list where you place them. For me, it is list 1, and my y's are in list 2. At this point, once everything is set up, it doesn't matter what mark you use. Remember, your calculator will automatically set up a window for you if you choose Zoom 9. That's your Zoom statistics window. The one thing I notice is you might see like a line going through my graph. It looks like I might have an equation in y equals. So I'm going to go ahead and clear them out real fast. Once I do that, I don't have to reset up the window. I can just hit graph again. And so essentially what you're asked to do now is to describe the relationship between the variables. And so I'd like you to go ahead and think about the shape, I'm sorry, not the shape, the strength, the direction, and the form. Let's make sure that we label these. So my x-axis would be the speed, and that would be in kilometers per hour. And then my mileage is going to be on the y-axis, and that's going to be in liters per 100 kilometers. Okay. And then when we're scaling it, if you just go to your window menu, you obviously don't need to enter any negative values, but if we think about my x-axis is essentially going from 0 to 164, and my y-axis is going from, I'm going to go ahead and keep the 0 there, to about, I'm just going to round to 25. Okay, and so that gives us the scale that we need to just kind of understand that image. So when you're describing the association, I think in terms of the strength of the association, I think there's a strong association, but it is clearly not linear. So when we're talking about the form, You want to make sure that you indicate that it is clearly not linear. When you're talking about the direction, I think you can see very clearly that the direction changes. Initially, the mileage decreases as the speed increases, but then it begins to increase. So when you're describing the association, you can simply say there's a nonlinear association between speed and gas mileage. Initially, the mileage decreases as speed increases, and then the mileage increases. Or you can simply say there's a change in mileage as speed increases. And again, just pointing out that it is a strong relationship. I think we can see that those points definitely follow a very clear pattern. What that pattern is, we're not sure. I know that if I were going to model it, I wouldn't use a straight line, though. There are lots of different functions that I could use. For example, it could be exponential, it could be logarithmic, it could be quadratic, and we'll explore those nonlinear associations at a later time. Okay. The other thing that we can do is add categorical variables to scatter plots very easily, in fact. So after examining the overall pattern of a scatter plot, we always want to look for deviations from the patterns, like outliers. And we also want to look for and outliers. There is no specific rule when we're dealing with scatter plots and outliers. I do want to point that out. If you remember when we were dealing with one variable data, we could look at the 1.5 times the interquartile range rule to identify an outlier for sure. With scatter plots, we do not have a rule like that. So an outlier is just something that is very subjective. It is a warning, though, if we do see an outlier in data. Sometimes it's a mistake in the way we collected the data, but sometimes it's an indication that there's something else going on and we need to look a little bit closer. So several outliers may suggest that there's another categorical variable affecting the data. It doesn't necessarily have to be categorical either. It could just be what we call a lurking variable. If it is categorical, though, we can use different colors or symbols to plot the points when you want to add a categorical variable to the scatter plot. It's also recommended that you use a different symbol. So if you have the same observation, so like let's say in the SAT data, I had two states that had the same mean math and mean verbal scores. So to show that I had two states on that same ordered pair, I could use a different symbol to represent the repeated observation. So here's another example. In number 4, it says metabolic rate, and that's the rate at which the body consumes energy, is an important study in the study of weight gain, dieting, and exercise. Researchers believe that lean body mass is an important influence on the metabolic rate, so they collected data on 12 women and 7 men who were subjects in a study on dieting. We actually looked at the data on the men already, I think, when we were looking at standard deviation. So this is a continuation of that problem. Lean body mass is given in kilograms, is a person's weight, leaving out all the fat. Metabolic rate is going to be measured in the calories burned per 24 hours. So the scatter plot, notice I've already given you the scatter plot, shows the relationship between the lean body mass and the resting the metabolic rate for the 12 women. So it says to determine the response variable and the explanatory variable. When you're given a scatter plot and it's already constructed for you, remember the explanatory variable is always going to be on the x-axis. The response variable will always be on the y-axis. And then it asks, is the association between these variables positive or negative? I think you can see that the high values of body mass are associated with the higher values of metabolic rate, and the lower values also are consistent with each other. So this would be a positive association. It asks about the form. I think it's pretty clear that this is a linear association, and it's fairly strong. Or you could say it's moderately strong, but I do think it's definitely not weak. So in the next part, it's saying, well, I also have data on 7 men who participated in the same study, but maybe there's a difference between the men and the women, and I want to be able to see that difference. If I plot the men using the same symbol as the women, I may not be able to distinguish between the men's data and the females' data. So one option would be to use either a different symbol or a different color to plot those points. So for example, if I start plotting the men, actually, why don't you go ahead and do that? Go ahead and press pause and then plot the data for the men in a different symbol or in a different color. Okay. So if you take a look at the men's data, I think you can see that the typical body mass for the men tends to be higher than the women, and it also continues to follow the trend where the higher values for body mass correspond to the higher values for the metabolic rate. So it says, does the pattern that you observed in part B, what we observed for the women, hold also for the men? And I think, yes, I think there's still a clear positive association. It's a little bit harder to tell because we don't have as much data for the men as we do for the women, but I do think a linear model may be appropriate, although it doesn't look quite as strong as it did for the women. And so it says, how do the male subjects as a group differ from the female subjects of the group? So this is where you want to use your comparison words. And I think here we can see very clearly that the body mass for men tends to be higher than it does for women, as does their metabolic rate. Okay, as a wrap-up, things you need to be able to do is to describe the difference between a response variable and an explanatory variable. Remember, the explanatory variable is going to correspond to that independent variable that you would do in science. It's going to be your X variable. It's going to be the thing that explains the response or the outcome. Number 2, describe one way to identify whether or not a relationship exists between two variables. So one way to do that, and I think probably the easiest way to do it, if you have the data, is to graph it. And then you can look very easily and see from the picture if there's an association between the variables. And in examining a scatter plot, what should you be looking for in the overall pattern? So this is where you want to look at the strength, the direction, and the form, and then any deviation such as outliers. And number 4, it says describe what is meant by a positive or negative association. And again, this is important that you can describe this without using the word positive. So for example, a positive association means that high values of one variable correspond to high values of the other, and that the low values also correspond to each other. In a negative association, it would be the other way. It would mean that high values of one variable correspond to the low values of the other, and vice versa. So it's important that you can explain those in words. Okay, so your homework, again, is just to finish filling out any other practice problems that you didn't get to in the classwork and turn in the completed classwork sheet next class. Have a great night.